The question is there is a quadratic function y is equal to -1 over 2x squared minus 6x minus 15, and its equation of x is equal to x is equal to p, and the function's maximum value is equal to q. And our ultimate goal here is solve for the p plus q. Before we solve for this question, let's think about in terms of the stuff that we need to think about when it comes to solving this problem. At first, we need to think about how to find the maximum values of the function. And secondly, we need to think about what it is to be x is equal to p from the function. Basically, they said it is an equation of x's, and we also need to think about what it is to be the equation of x's. At first, let's think about what it is to be a function. For a function, it is some kind of thing that always requires a specific input on it. So when we require a specific input, there will obviously going to be a specific output of the function. And this is how the function works. And now let's think about what it is to be an equation of axis. So for the axis of axis equation, we know that for the question it says x is equal to p. In order to think about axis equation, let's think about a basic format of a line. And this is not a quadratic function like y is equal to -1 over 2x squared minus 6x minus 15, because this term doesn't contain a square, which means when you graph this, it will going to be a specific line. If you think about our original equation for a line, it is equal to y is equal to x. So basically what we added here is x values are same, but we replaced p as y. So we can think about in this way, it will going to be a line if we graph it. So if you think about P as some point right over here, it can be both negative or positive, depends on situations. If you graph a line, it will going to be something look like this. So it will going to be something that look like this that passes through our point. And our point here is P. The reason is because we know that x is equal to p, which means even though we input the value of x value, the y value should always be equal to p, as we see right over here. So this line is p is equal to x. And let's think about when the p value is right over here. When the p-value is negative, it is same kind of thing that the line will look something like this that passes through our point P. And this will turn into negative P is equal to x. Even though when we input the value of x value, it will still going to be a negative P. And this is what axis equation means. Let's think about it in another way, where it's not x is equal to p. Let's say that when the value is equal to y is equal to p. And for here, what we did is we replaced p as the x value, which means the p value will going to be a x value. And if you see that p is right over here because we don't know exact value of it, the line will look something like this that passes through our point P. Which this graph means even though when we input the value y values, it will still going to be a p value. So let's think about in terms of when the p value is negative. So the case when the y is equal to negative p. So when you see that the value p is right over here, the graph will also be something like this that passes through our point P, and even though when we input the value of the y value, it will satisfy our value P. And this is what axis equation means. We figure out what is axis equation, so let's think about how to solve for this. The way to do it is at first we need to convert this into a vertex form. We also call vertex form as a perfect square form. The reason why we're converting this into a vertex form is because here we basically don't exactly know what is the x specific value. So in order to find the value of the x value, we need to some kind of convert this into some kind of form. And vertex form is a form that we can figure out the axis of equations. So let's get through it. So let's just write our function down again. Y is equal to negative 1 over 2x squared minus 6x minus 15. When it comes to solving for the vertex form, only terms that we are caring about is a variable terms. So we kind of need to separate them by putting a parenthesis in it. Negative 1 over 2x squared minus 6x, and there will be something. And then we still have it left over, but we cannot erase it, which means we need to write it, negative 15. But if you think about the leading coefficient, which is negative 1 over 2, if it is not equal to 1, it's kind of hard to calculate, hard to factor it out. So the way to remove this is we write negative 1 over 2 out. And what we did is we kind of multiplied 2 to the every single terms, which means we multiply 2, we still have x squared. We multiply 2, which will turn into negative 12x. But we need to think about in this way. We are taking out the negative, which means we also have to multiply negative. And we are multiplying basically negative 12. So we're going negative 2, which will going to be positive 12. And there will be some number right over here. But for the number, there is a formula for finding it. The formula is we need to take a half of the front number, which is just 12. It is basically 12x, but we're caring about numbers. And then if we square it, it is a formula for finding the constant. So for doing this, 1 over 2 times 12 is 6, and the square will turn into positive 36. And we still have negative 15. But since we added 36 here, we need to subtract 36 here to kind of make this function equal, because if you just add 36, it will going to affect our original function. But we can think about in this way. When you divide, use this derivative property, 1 over 2 times 36, it will turn into 18, which means we don't really have to add negative 36. Only thing we need to do is add 18. And now we kind of finished it here, but negative 15 plus 18 will turn into a positive 3, and we have parentheses. But for x squared plus 12x plus 36, but we still had negative 1 over 2, we can kind of factor it out into x plus 6 squared. And this is the whole point why we convert this into a vertex form. We can see that it is a vertex form. And this is the reason why we convert this into a vertex form. And for the vertex form step, we need to remember that we always have to make this into a perfect square. And at first, if you think about the vertex form, it is negative 1 over 2, x plus 6 squared plus, it is basically plus 3. And if you think about this vertex form, we know that we usually call this A which defines our slope of the function. We had talked about this in lots of videos, and only thing it kind of affects is when I would call this a, and when the a value is greater than 0, which means when it is positive, the graph will go upward. When the a value is less than 0, which means when it is negative, the graph will go downward. This is what the a affects. It doesn't really affect when it comes to graphing, but it affects the type of the graph of the function. And now, if you think about the x is equal to p, in this case, x value will going to be right over here. But for defining the value of the x value, we kind of, it is a property of the vertex form. The value of the x should always be the value that makes this expression into 0. This is what the property is. And if you think about x plus 6 is equal to 0, in order to isolate the x terms, we can kind of subtract 6, and then we get x is equal to negative 6. And we always need to remember this is a property of our function vertex form. And from here, we can see that our value of the x is negative 6. So we can kind of input the value to our x value. So negative 6 is equal to p since we inputted the value of the x into negative 6. And right now, our ultimate goal in this question is solve for p plus q. So p plus q. And for a p value, it is negative 6, which will turn into negative 6 plus q. And right now, only thing that we need to find is the q. The q value is a maximum value of our function. And at first, we don't have to convert this again into this term because for this term, we cannot find the maximum value. And let's write our function down again. Negative 1 over q times x plus 6, and then square plus 3, and that is obviously going to be equal to y. And if you think about this, let's input the value of x. We know that x is a value of input value, and y is a value of the output value. Let's input the value as a positive value. When we input the value of positive, let's just input the value of 1. 1 plus 6 is equal to 7. Square is 49. But we have a times negative, which means even though whatever we input the value of positive, it will going to give us the value of negative. Let's think about what will happen if we input the value of negative. When we input the value of negative, let's think about negative 4 or negative 7. If you input the value of negative 7, it will turn into negative 1. And then square will turn to 1, but we also have multiply negative, which means even though we input the value of negative, it will turn into negative value. And we can kind of figure out something here. That even though we input the value, it will going to be negative, and it will subtract from our only positive value, which is 3. So if you kind of think about it, our maximum value of our function will going to be the value when this term is be equal to 0. So maximum point is 1 over 2 times x plus 6 squared is equal to 0. And if this turns out into 0, our output of our function, which will going to be our y, and y will also going to be our maximum point, y will going to be just positive 3. And our positive 3 is our maximum point of our function. And this is the way how we figure out the maximum point. But this is not our ultimate goal of our function, of this function problem. Our ultimate goal is adding p plus q. And for a p value, we know that it will going to be a equation of axis which will going to be -6. So we can kind of convert this into -6. And for a q value, we know that it will going to be +3. If we add it, it will going to give us an output, which is answer -3. So we can see that our answer for this question will going to be -3.